Early life and family background. Francis Galton was born on February 16, 1822, near Birmingham, England, into a wealthy and well-educated family. His parents, Samuel Tertius Galton and Francis and Violetta Darwin, belonged to two influential families: the Galtons, known for banking and industry, and the Darwins, famous for science. From a young age, Francis displayed an exceptional curiosity about the natural world. He could read by age 2 and solve complex math problems by 5. Surrounded by books and encouraged to observe nature, Galton's early years were filled with intellectual stimulation. His privileged upbringing allowed him access to excellent education and scientific resources, setting the stage for a life dedicated to exploration, measurement, and discovery. Education and early interests. Galton attended King Edward School in Birmingham before moving to Trinity College, Cambridge, in 1840. Initially studying mathematics, he was brilliant but restless. His academic journey was interrupted by a mental breakdown, partly due to the pressures of study and family expectations. Though he earned a degree in mathematics in 1844, his interests had already shifted toward medicine, geography, and meteorology. Galton's time at Cambridge exposed him to scientific thinking and experimentation. He began keeping detailed notes and conducting small-scale studies on human behavior, climate, and statistics. These early intellectual pursuits would later evolve into groundbreaking research in psychology, genetics, and human measurement. African exploration and adventure. In the 1840s and 1850s, Galton sought adventure beyond academic life. In 1850, he embarked on a daring expedition to southwestern Africa, exploring what is now Namibia. His journey was perilous, filled with dangerous wildlife, harsh climates, and unfamiliar tribes. Yet, Galton's curiosity drove him to record everything he saw with scientific precision. He mapped uncharted territories, collected data on local populations, and studied environmental conditions. The expedition earned him fame and respect in the Royal Geographical Society, which later awarded him a gold medal for his discoveries. These experiences not only strengthened his reputation as an explorer, but also taught him the value of systematic observation and measurement, a theme that would define his later work. Influence of Charles Darwin. Francis Galton's cousin, Charles Darwin, published On the Origin of Species in 1859. The book deeply influenced Galton, who became fascinated by the idea of evolution and heredity. He began to wonder if the principles of natural selection could apply to human intelligence and talent. Galton's correspondence with Darwin was frequent, and he admired his cousin's groundbreaking work. However, Galton wanted to take Darwin's theory further, beyond animals and plants, to understand human potential. He started collecting data on family histories, physical traits, and mental abilities, searching for patterns of inheritance. This marked the beginning of his lifelong quest to study human variation scientifically, which later gave birth to the controversial field of eugenics. The birth of eugenics. By the 1860s, Galton began formulating ideas that would later be known as eugenics, a term he himself coined in 1883. Derived from the Greek word meaning well-born, eugenics was Galton's attempt to improve the human race through selective breeding. He believed that intelligence and moral character were inherited traits, and that society could advance by encouraging the reproduction of the fit. While he saw it as a positive scientific movement, his ideas later became ethically problematic. Still, Galton's theories profoundly influenced genetics, sociology, and social policy debates for decades. He viewed eugenics as an extension of Darwin's natural selection, applied to humanity itself. Studies in heredity and statistics. Galton's curiosity about human ability led him to develop new methods of measurement and analysis. He gathered data from families, schools, and universities to explore patterns of inheritance in intelligence and behavior. To interpret this data, he introduced statistical techniques such as regression and correlation, laying the foundations for modern statistics. He also created the first normal distribution curve to represent variations in human traits. Galton's combination of data collection and mathematical analysis was revolutionary. For the first time, social and psychological questions were studied with quantitative precision. His methods continue to influence scientific research and psychology today. Fingerprints and forensic science. In the 1880s, Galton turned his attention to human identification. He became fascinated with fingerprints, noting that no two individuals shared the same patterns. Through years of careful study, he developed a classification system that made fingerprint identification practical and reliable. His 1892 book, Fingerprints, became a foundational text for forensic science. Law enforcement agencies worldwide soon adopted his techniques for criminal investigations. This was one of Galton's most enduring contributions, a system still in use today. He had successfully transformed a simple biological curiosity into a groundbreaking tool for justice and human identification. Meteorology and weather maps. Apart from human studies, Galton made significant contributions to meteorology. He was the first to create weather maps showing patterns of air pressure and wind flow. His invention of the term anticyclone helped explain large-scale weather systems. In the 1860s, his work with the British Meteorological Office laid the foundation for modern weather forecasting. Galton's systematic data collection and visualization methods allowed scientists to predict storms and understand atmospheric behavior. His passion for measurement extended from people to the environment, always seeking order, pattern, and predictability in a natural world. Psychology and mental measurement. Galton is often called the father of psychometrics, the science of measuring mental abilities. He built laboratories where he tested individuals' reaction times, memory, and sensory perception. His anthropometric laboratory, established at the 1884 International Health Exhibition in London, allowed the public to have their mental and physical abilities measured scientifically. He introduced the concept of testing intelligence through observation and data rather than intuition. Although his early tests lacked modern rigor, they paved the way for future psychological assessment and intelligence testing. Galton's belief that what can be measured can be improved became a cornerstone of scientific psychology. Later life and recognition. In his later years, Galton's fame as a scientist was well established. He received numerous honors, including being knighted in 1909 for his contributions to science. Despite controversy surrounding his eugenics work, he remained deeply respected for his innovations in statistics, psychology, and biometrics. Galton continued writing and experimenting well into his 80s, always curious about new questions and eager to apply mathematics to human problems. He spent his final years in Haslemere, England, enjoying quiet research and correspondence with younger scientists who admired his pioneering work. Death and legacy. Francis Galton died on January 17, 1911, at the age of 88. He left behind a vast legacy that continues to shape modern science. His development of correlation, regression, and fingerprint identification transformed multiple disciplines. However, his advocacy for eugenics also cast a long shadow, later misused by extremist movements in the 20th century. Despite this, Galton's broader contributions to measurement, psychology, and data analysis remain invaluable. He demonstrated how mathematics could unlock the mysteries of human nature, though his moral conclusions were debated for generations. The dual legacy of Francis Galton. Today, Francis Galton is remembered as both a brilliant innovator and a controversial thinker. His scientific methods revolutionized data collection and analysis, giving birth to entire fields such as biometrics, psychometrics, and statistics. Yet his eugenic ideas remind us how easily science can be distorted by social bias and moral blindness. Galton's life reflects the paradox of scientific ambition, the drive to understand and improve humanity, sometimes without fully understanding its ethical limits. In the end, Galton remains one of the most complex figures in modern science, a man who sought to measure human greatness and, in doing so, revealed both the power and peril of scientific thought.